Welcome to this course. Myself, Dr. Nitin Abhiman Mirgani. Today, we are going to see stereoselective and stereospecific reaction. What is addition of bromine to cis-2-butene? Now here, we can see mechanism. This reaction takes place in two steps. Now, first bromine is added and we get cyclic cyclopropene cation. Now, this bromide ion will attack in two ways, path A and another is path B. So, path A, you get one isomer, and here path B, you get second isomer. So, overall, you get 50-50, that is, a racemate will be obtained. Next is addition reaction of bromine to cis-2-butene. Now here, again, we get to that pathway. So, how to show in the, how to explain this? Just path A, you get staggered eclipse, and finally you get the Fischer form. So here, now this reaction, now here is CH3, this is cis-2-butene, CH3, here is also CH3, here is H, here is also H. Now path A. So how path A means bromine is added anti-way. So this is the pathway. If this bromine is added at this carbon, so this will be added from the bottom. Simultaneously, what happened? This ring gets opened. So this another bromine will be added from the top. Now what happened? So this is the path A. We are discussing only path A. So what is a path A? If bromine is added from the bottom, so you get regular Y. If bromine is added from the top, you get inverted Y. Now here what you get in, this is a, for this is a carbon number, suppose 1, this is 2, this is carbon number 3, and this is carbon number 4. So what happened here? We get this structure. So this is, one is structure in the form, and this will be like this way. So this is, one is regular Y, other is inverted Y. So this is, meaning is that bromine add anti to each other. So this is a staggered form. So when we want to write the staggered into Fischer form, directly we cannot write. We have to convert this staggered into eclipse. So how to convert this? So we have to convert this second carbon, this inverted Y, we have to convert into regular Y. So we have to rotate through this second carbon at 180. So how to rotate 180? Like this way. These bromines come at this position. So here, this bromine. Okay, which bromine? This CH3, we have to rotate through 180 degree. So here, at this position. This H means we have to write here. Okay. So this is the position after rotation through the C2 180 degree. So this becomes eclipse, a regular Y. Now, but at the longest this carbon, we want this CH3 here, okay, at this position. So we will rotate this through 120 degree, okay, like cyclic manner. So if you rotate through 180 degree, what will happen? This CH3 will come at this position. So here you can check this. This bromine will come at this position. So here, and this H will come at this position, okay, this position, like this way, okay. And for this also, what we will do, we will rotate anti-clockwise like this way. So this bromine will come here, here. You can check. This H will come at this position, this, okay. And this CH3 will come at bromine position. Here we are written, okay. Now, next will be how to write this 1, 2, 3, 4 carbon we have labeled. So this CH3 at longest. Now this bromine is at the second carbon at the right hand side. H will be on the left hand side. Then this H will be on the right hand side. Here we have written. This bromine will be at this position. Okay. So this is in Roman structure number 1. Next will be next is path B. So what is path B? So just see the path B. Path. Okay. Path B. Here is also CH3. Same CH3. This is cis2 butene and path B we are discussing. This will be H. This will be H. Path B. So now path B. So how ring gets open? This bromine will be attacked from the bottom. So at this you get a regular one. Here is the regular one. Just see the regular one. Bromine is added from the bottom. Then a ring gets open at this from the top. So this bromine will be added from the top. So this becomes inverted Y. You can check here. Okay. So now this bromine anti to each other. So this is the staggered. So regular Y, no problem. So we don't have to convert this. So what is the next? Next will be we have to convert this inverted Y into regular Y. So rotate through 180 degree. So this staggered we have to convert into this eclipse form. So how will convert this bromine at this position? Okay, this position. So you can check here. This CH3 will be at this position. So you can check here. This H will be at this position. So here H after rotation through 180. So this becomes eclipse. Now CH3 should be at the longest position. So what we have to do? This we have to rotate through 120 degree. And this you can rotate this at through the 120 degree. So this CH3 at this position. So you can check here. This H will be at this position here. So you can check. And this bromine at this position. So you can check here. Okay. Next will be this CH3 at this position. You can check here. This H at this bromine position. So you can like this way. Sorry. So this H will be at CH3 position. Okay. And this bromine will be at H position here. You can check. Okay. Now next will be now if you look at through this and if you want to write the feature, this H will be on the right hand side at second carbon. This bromine will be at the left hand side. This bromine at the right hand side here. this HV will be on the left hand side, and you get this is the second structure. So what is the relation between first and second? Just check first and second. Okay, first and second. What is the relation? Okay, so they are, okay, we have seen already here. Okay, cis to butene. So what we get here? We get the racemic. So that is true. Okay, means this reaction is stereoselective as well as stereospecific in nature. Next is just a recap. Just a recap of this. Another is bromination of trans to butene. What happen here? Again, bromine will be added. Just see the position of this CH3 and CH3. Okay. Okay. Now just check the position of this. Okay. You get stagger rotation. Here, rotate through 180 degree. Eclipse, you get this. And okay. So just see this mesoform structure. Path B. Okay. Means you get the mesoform structure. Thank you very much.